questions. I have 10 questions here, and we will discuss each and every question in detail. Okay, so let's see the very first question. This is the very first question. Various time they already asked that types of question. They will give you the grammar, and they can ask you after the left recursion which is the option. Okay, means what will be the grammar after removing what? Left recursion. So this is the question. Read the question carefully. सबसे पहले आप क्वेश्चन को अच्छे से पढ़िए. After removing left recursion from the following grammar, this is the grammar. Suppose this is any production of the given grammar. Okay, this is the grammar. The resulting grammar will be. So resulting grammar में कौन से productions आ जाएंगे? ठीक है, when we are going to eliminate the left recursion. Okay, so if any production like this in any grammar, if any production like this in any grammar, then grammar 100% contains what? Left recursion. वो क्या है? उसके पास left recursion है. So as we know that left recursion is a problem of the top down parser. Okay, means top down parser is not able to recognize what? Left recursive grammars. Okay, so that's why we need to remove it. Okay, so this is a left recursion. अगर इस टाइप का कोई प्रोडक्शन हमारे किसी भी ग्रामर में प्रेजेंट है, so उसके पास लेफ्ट रिकर्शन है, हमें उसको रिमूव करना है. दिस इज द प्रॉब्लम ऑफ द टॉप डाउन पार्सर, राइट? LL1 parser. Okay, so when we are going to remove that types of production, means left recursion from the grammar, then we need to add two more productions. We need to add two more productions at the place of this production. At the place of this production, इस प्रोडक्शन की जगह जो इस टाइप का प्रोडक्शन है जो लेफ्ट रिकर्सन कंटेन कर रहा है, उसकी जगह हम लोग दो नए प्रोडक्शंस ऐड कर देंगे ग्रामर में और उस प्रोडक्शन को वहां से एलिमिनेट कर देंगे. सो वो दो नए प्रोडक्शंस कौन से होते हैं? A टेंड्स टू A अल्फा स्लैश बीटा. सो हम लोग दो नए प्रोडक्शन इस प्रोडक्शन की जगह ऐड कर देते हैं व्हेन वी आर गोइंग टू रिमूव व्हाट? लेफ्ट रिकर्सन फ्रॉम द ग्रामर. And what are these two new productions which we need to add at the place of this production? Okay, so A tends to what? A tends to beta A dash. Okay, and after A dash to what? Alpha A dash slash epsilon. Alpha A dash slash epsilon. So at the place of this production, okay, we need to add these two new productions in the grammar. So when we will add these new two productions at the place of this left recursive production, then grammar is free from the left recursion. तो हमारी grammar क्या हो जाएगी? Free from the left recursion हो जाएगी. So let's check कि कौन कौन से options हमारे सही हैं. So at the place of this left recursive production, we need to add two new productions, as I told you, at the place of this production, left recursive production. So A tends to beta A dash. Yes, A tends to beta A dash, but here A dash tends to alpha A dash. Here what we have? We have epsilon also. So that's why option A is wrong. Come on, option B. A tends to what? Alpha A dash. Completely wrong, because A tends to what? Beta A dash. So no need to check further. Okay. Come on, option C. A tends to beta A dash. Yes. First production is this. Yes. A dash to alpha A dash. Yes. Slash epsilon. Yes. So yes, option C is correct here. Option C is correct here. To remove the left recursion or to eliminate the left recursion from any grammar, we need to add these two productions. Okay, and here A tends to alpha A dash, and the first production which we need to add is here is what? A tends to beta A dash. First production here is wrong, so no need to check further. So clearly option C is correct here. That types of question they can ask you, and various times they asked already. They will give you any grammar, and they can ask you what is the grammar after the left recursion. वो grammar आपको option में दे देंगे. After the left recursion की जो grammar होगी वो they will give you that grammar in the options. This is the question number first. Let's see the question number second. Consider the following grammar. This is the given grammar. S tends to IETS slash IETS ES slash A terminal. E tends to B. Okay. They asking you what? After removing left factoring, the resulting grammar will be. ओके, सो टॉप डाउन पार्सर की दो प्रॉब्लम होती हैं. टॉप डाउन पार्सर हैव टू प्रॉब्लम्स. फर्स्ट वन इज व्हाट लेफ्ट रिकर्शन एंड सेकंड वन इज व्हाट लेफ्ट फैक्टरिंग. सो वी नीड टू एलिमिनेट दीज टू प्रॉब्लम्स. उसके बाद ही LL1 पार्सर उसको पास कर पाएगा उस ग्रामर को. अगर उस ग्रामर में इफ इन द ग्रामर इज प्रेजेंट व्हाट लेफ्ट फैक्टरिंग और लेफ्ट रिकर्सन, देन LL1 पार्सर इज नॉट एबल टू पास दैट टाइप्स ऑफ ग्रामर. सो अगर LL1 पार्सर से हमें ग्रामर को पास कराना है, सो हमें लेफ्ट रिकर्सन और लेफ्ट फैक्टरिंग की प्रॉब्लम को रिमूव करना होगा. ओके, so what is the left factoring here? Suppose you have the grammar like this: A tends to what? Alpha beta 1 slash alpha beta 2 slash alpha beta 3 slash dot 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 dot. अगर इस टाइप का प्रोडक्शन है, सो हमें क्या करना होगा, इस प्रोडक्शन को रिमूव करने के लिए ग्रामर से. ओके, इफ in the grammar we have that types of productions, okay, then to remove that production from the grammar, and that production is called what? Left factoring. So you can say that to remove the left factoring from the grammar, we also need to add two more productions. We also need to add two productions at the place of this production, at the place of this production. And what are these two productions जो हमें ऐड करने हैं at the place of this production to eliminate the left factoring from the grammar? So very simple, A tends to alpha A dash, okay, and after that A dash tends to beta 1 slash beta 2 slash beta 3 slash dot dot dot. जितने बीटा होंगे सब ऐसे हम लोग स्लैश करके लिखते रहेंगे. ठीक है, सो अब हम लोग अपनी ग्रामर पे आ जाते हैं. लेट्स कम ऑन द ग्रामर. So here you can clearly see from here this one is what? Alpha. This one is what? Alpha. And after that beta 1 here is what? Epsilon. Beta 1 here is what? Epsilon. Means after that no other characters or terminal is present. So beta 1 is what? Epsilon. In this, so this is alpha beta 1. Come on the second production, IETS. This is what? Alpha again. Okay, alpha beta 1, alpha beta 2, this is what? Alpha again. This whole thing is matching this whole thing. So this is nothing but what? Alpha. Okay, and this whole thing will become what? Beta 1. Okay, so yes, left factoring is present in these two productions. So we need to eliminate it. So कैसे eliminate कर सकते हैं? How we can eliminate? By adding these two productions at the place of this left factoring type of production. Okay, सो हम लोग इसको एलिमिनेट करते हैं. सो एलिमिनेट करने के लिए ए की वैल्यू यहाँ पे व्हाट इज ए हेयर, दिस एस. ओके, जब कंपेयर व्हेन वी आर गोइंग टू कंपेरिजन, जब हम इसको कंपैरिजन करेंगे, सो एस इक्वल टू व्हाट? ए हेयर. ओके, सो एस टेंड्स टू मीन्स ए टेंड्स टू, एस टेंड्स टू अल्फा हेयर इज व्हाट? आई ई टी एस अल्फा ए डैश. ए डैश इज नथिंग बट व्हाट? एस डैश. Okay, come on the second production, A dash is nothing but what? S dash, S dash 2. Okay, beta 1 slash beta 2, beta 1 slash beta 2, beta 1 here is what? This is what? Beta 2. This is what? Beta 2. Beta 1 here is what? Epsilon slash beta 2 here is what? ES. और यहाँ पे ये एप्साइलन ए तो है ही है स्लैश में, जो ओरिजिनल प्रोडक्शन ए है वो हम वहाँ रखेंगे उसको. And after that E tends to be, we already have in the grammar. So this is the grammar, this is the grammar after eliminating what? Left factoring from the grammar with the help of these two productions. Okay, let's check which option is correct here. S tends to IETS, S dash slash A, yes. S dash to ES slash epsilon, no problem. ES slash epsilon, yes, no problem. And E tends to B, yes, E tends to B. So yes, here option A is correct, means this is the correct option in which you have the grammar after the left recursion. Okay, here this is wrong because ES doesn't, after ES we need to have what? Epsilon, that's why it's wrong. It is also wrong because E tends to B is not there, and this is also wrong. So completely which option is correct here? Option A is correct here. Okay guys, so I hope you understand. Let's see the next question. This is the question number 3rd. Every SLR1 grammar is, so we have the relationship between all the bottom up parsers. Okay, so here what we have, here we have what, LR0. After that what we have, SLR1. We have the relationship between all top down and bottom up parsers. So this is a very important diagram. After that what we have, LALR1. After that what we have, CLR1, and it is also, you can say that what, LR1. And here what we have, here we have LL0, LL1 parser. Okay, so this is the relationship of the parsers. So every SLR1 grammar is, so every, this is a superset and subset concept. So every SLR1 grammar is what? Every SLR1 grammar is what? LALR1 grammar and LR1 grammar or CLR1 grammar. So let's see here. Not an LR1 grammar, no. This is a wrong option. Yes, every SLR1 grammar is what? CLR1 grammar or LR1 grammar. So that's why it's a wrong option. Maybe an LR1 grammar, maybe nahi, exactly all, because it's a subset of the LR1 grammar. So all SLR1 can be, all SLR1 always what? CLR1 or LR1. So maybe का concept तो यहाँ है ही नहीं. Sometimes not an LR1 grammar, no, this is also wrong. And LR1 grammar, yes, always what? Always वो क्या होती हैं? All SLR1 grammar, always what? LR1 grammar or CLR1 grammar. So that's why option D is correct here. Guys, this is a very important diagram in the compiler design, means relationship between all the parsers, top down parser or bottom up parsers. So you need to remember this diagram. Through this diagram you will get questions. Okay, this is the question number 4. Let's see, read the question carefully. In compiler, which of the following code replacements is an illustration of operator strength reduction? Okay, so first we need to understand what is operator strength reduction in code optimization. So in operator strength reduction, we need to replace the higher cost operator with lower cost operator, okay, to reduce the cost of the program. Okay, so let's see here, as I told you, and also you know that. Okay, so asterisk here is what? Asterisk is higher cost operator as compared to what? Plus and left shift or right shift. Okay, so asterisk is what? Higher cost operator, higher cost operator, operator as compared to either left shift or right shift and plus operator, you need to remember this thing. जब आपको ये चीज़ पता होगी आप आराम से क्वेश्चन को कर ले जाओगे. ठीक है, बहुत बार ऐसे क्वेश्चन पूछे जाते हैं. ठीक है, so it is asking you which code replacement is an illustration of operator strength reduction. Okay, यहाँ पे देखते हैं हम लोग, replace p plus py asterisk. So here plus is a higher cost operator as compared to multiplication or asterisk operator. So here we are reducing this plus by asterisk, so definitely it's a wrong option. Okay, it is violating the condition of the operator strength reduction. Okay, option B, replace p asterisk 0 by 0. So where is what this p? So this is again wrong option. Replace p left shift 4 means p को 4 times left shift करना है, minus p by p asterisk 15. Okay, so again a wrong option, because where this p, what we are doing with minus operator. Okay, come on option D, replace p asterisk 32 by p left shift 5. Okay, yes, here we are going to replace this asterisk with left shift. Okay, so yes, this option is correct, because asterisk is a higher cost operator as compared to a left shift or right shift operator. So option D is correct here. Option D is correct here. Okay guys, option D is correct here. So this is again a good question. Let's see the question number 5. This is the question number 5. इसको carefully पढ़ते हैं हम लोग. Which of the following is false? मतलब कौन सा ऑप्शन इसमें से false है? So let's check the option. द ग्रामर गिवन है पहले ऑप्शन में, एस टेंड्स टू व्हाट, ए एस बी स्लैश बी एस ए स्लैश एस एस स्लैश एप्सिलॉन स्लैश व्हाट, एप्सिलॉन. So it is saying you what the grammar, this is ambiguous, so we need to check it's a ambiguous grammar. It's a what, ambiguous grammar. So S tends to what, a alpha slash beta, a alpha slash beta. मतलब अगर ग्रामर में हमारा लेफ्ट रिकर्सन के टाइप का प्रोडक्शन प्रेजेंट है, सो ग्रामर ऑलवेज बी व्हाट, ambiguous. If in the grammar we have what, left recursion type of production, then grammar is always what, ambiguous. Okay, so you can check from here, from this production, S tends to, you can check from this production, S tends to this SS slash epsilon, SS slash epsilon. So this is nothing but what, S tends to SS slash epsilon. So here A tends to what, A alpha, A tends to what, A alpha slash beta. So this is what, this is A tends to what, A alpha, this is A, and this can be what, alpha, and A alpha slash beta, and beta is what here, epsilon, beta is here is what, epsilon. So yes, in the given grammar left recursion is present, in the given grammar left recursion is present, left recursion is present, left recursion is present, left recursion is present, and the grammar in which left recursion is present always what, ambiguous, always what, ambiguous. This is the one way, and the another way is what, you need to generate the pass tree for any string, you need to generate what, the pass tree for any string that is generated by the given grammar. Okay, if you are getting more than one pass tree for a single sentence or for a single string, okay, then the grammar is what, definitely ambiguous. So this is the way. And second way, as I told you, you can check the grammar is ambiguous or unambiguous through the string. Means for a single string, if you are getting more than one pass tree, then ambiguous, or if you are getting only one pass tree for a string, then it's what, unambiguous. Okay, so yes, this is what, ambiguous, this is what, ambiguous. So this is not a false, this is a true statement, this is what, this is a true statement. Okay, answer will what, answer कौन सा होगा, which statement is false here. SLR1 is powerful than LALR1, no, you can check from the relationship, SLR less than what, LALR less than what, CLR. So SLR is less than from LALR, not powerful. Okay, not powerful. So yes, this is a false statement, this is a false statement, and this is the answer, this is the option B is correct here. This is a false statement, and option, and false statement is your answer. वो आप will your answer, false statement ही आपका आंसर हो जाएगा. So yes, option B is correct here. Let's see how option C is correct here. And LL1 parser is a top down parser. Yes, LL1 parser is a top down parser. This is a true statement. Yak tool is a LALR parser generator. So as we know that we have two way to generate the parser. First one is what, hand code, and second one is what, tools. So Yak is what, yet another compiler, and we have the another tool is Wyson. These are the two tools to generate what, to generate the parsers, and we also have one method what, hand code. So yes, Yak tool is a LALR parser generator. Yes, this is also a true statement. So which option is correct here? Clearly option B is correct here, because it is asking you about the false statement in the option. So false statement कौन सा हमारा ऑप्शन में, B है. कौन सा है, B है. Okay, let's see the question number 6. Read the question carefully. Which one from the following is false? It is again asking you the false statement. Okay, that types of questions बहुत पूछे जाते हैं, इस टाइप के क्वेश्चंस एग्जाम में. ठीक है, क्योंकि वहाँ पे सारे कॉन्सेप्ट आप वो अप्लाई कर देते हैं और आपसे फॉल्स स्टेटमेंट पूछ लेते हैं. ठीक है, LALR पार्सर इज बॉटम अप पार्सर. यस, बॉटम अप पार्सर में आपके कौन से आ जाते हैं? बॉटम अप पार्सर में आपका शिफ्ट रिड्यूस पार्सर आ जाता है. शिफ्ट रिड्यूस पार्सर इज ऑल्सो बॉटम अप पार्सर, शिफ्ट रिड्यूस पार्सर. And after that what, LR parser, and LR parser further divides SLR, LALR, and what CLR. And we have another parsing technique. This is also a bottom up parser, operator precedence parser. Operator precedence parser. Okay, so let's see. It is first statement is saying what? LALR parser is bottom up parser. Yes, it's a true statement. So which statement is here false? Then that will be the answer. वो आपका आंसर हो जाएगा. A parsing algorithm which performs a left to right scanning, okay, and the rightmost derivation is RL1. So this is any type of parser? No. So that says that this is a false statement. Clearly this is a false statement. Okay, come on, the option C means why it is a true statement. LR parser is bottom up parser. You can clearly see from here, this LR parser is what? Bottom up parser. Yes, this is again true statement. Okay, option D को check करते हैं हम लोग. In LL1 the indicates that there is a 1. In LL1 1 indicates. In LL1 here is what? 1. The 1 indicates LL1. In LL1 the, यहाँ पे ये D है, the 1 indicates, यहाँ पे the 1 indicates what? 1 यहाँ पे क्या indicate कर रहा है? Length of look ahead symbol. Length of look ahead symbol means at a time it can read only one terminal. Okay, so length of look ahead symbol, LL1, the 1 indicates that there is a one symbol look ahead. Yes, this is the meaning. That's why this is what? True statement. So which one is here? False. B is false. That's why B is a right answer. That's why B is a right answer, because it's a false statement. Okay guys, so इस टाइप के क्वेश्चन बहुत पूछे जाते हैं कंपाइलर से. सारे कॉन्सेप्ट वहाँ पे अप्लाई हो जाते हैं आपके एक ही क्वेश्चन में, वो आपसे सब कुछ पूछ लेते हैं. So this is the question number 7. Again a good question. Which of the following related to a compiler is wrong? कंपाइलर से रिलेटेड कौन सा स्टेटमेंट यहाँ पे फिर से रॉन्ग है? ओके, lexical analysis is breaking the input into tokens. Yes, lexical analysis takes what? Source program as a input and breaks the source program into tokens based on the keywords, identifiers, strings. Okay, so yes, this is a true statement. जौन सा स्टेटमेंट यहाँ पे क्या होगा? रॉन्ग होगा, वो हमारा आंसर हो जाएगा. Syntax analysis is for parsing the phrase. Yes, syntax analysis takes what? Tokens, a stream of tokens as a input and produce what? Parse tree. Means syntax analysis phase also works as a parser. You can say it as a parser also. And lexical analysis phase you can say it's a scanner. Okay, so both the statement are correct, not wrong. This is a correct statement. This is also a correct statement. Let's see, or let's check the option C. Syntax analysis is for analyzing the semantics. No, syntax analysis is not for analyzing the semantics. Semantic analysis is there for analyzing the semantics. Okay, so this is what? Wrong statement. This is what? Wrong statement. So that's why option C is correct here. Option C is correct here. ये हमारा wrong statement है और यही आंसर हमारा सही है. And option D is none of these. So that's why option C wrong, and it is asking about the wrong statement in the compiler. So that's why option C is correct again. Okay, अब हम लोग अपने next question को देखते हैं. Question number 8. A shift reduce parser suffers from. Shift reduce parser किससे सफ़र करता है? ठीक है, shift reduce conflict. सबसे पहले हमें ये जानने की ज़रूरत है. First we need to understand what is shift reduce conflict and what is reduce conflict. So suppose in any state, during the calculation of canonical items, in any state you have the protection like this. S tends to what? S tends to what? S tends to what? A S. Okay, and here you have what? A tends to what? This A. Like that types of protection you have in any canonical set of item states. Suppose this is a canonical set of item states 2. Okay, so when here we will give as a input what? A, then it will move to the next state. So next state, suppose this is what? I3. So here on A, this dot is shifting here. So S tends to what? This A dot S, A dot S, okay, and the here A tends to, when you are giving A, then this dot is completely shifted here. So this production is completely going to what? Reduce, and here on A this dot is shifting. So that types of conflict is called what? Shift reduce conflict, shift SR conflict, shift reduce conflict. And what is reduce reduce conflict or reduce reduce conflict कौन से होते हैं? So suppose you have the any state in your during the calculation of the canonical set of items like this, S tends to what? S dot A, and A tends to what? Dot A, like this, and you are giving here what? A. So both the productions here is going to what? Reduce. Both the productions is here is going to what? Reduce on the next state of the canonical set of item when you are giving what? A. So S tends to what? S A dot, this is also going to reduce, and A tends to what? A dot, this is also going to reduce, means on the A operator both the productions here is going to what? Reduce. So this is called what? RR, reduce reduce conflict. If you are getting that types of conflict during the calculation of canonical set of items, so these are the concepts. Let's check the option. So a shift reduce parser suffers from, दोनों से suffer करता है, it suffers from shift reduce conflict and reduce reduce conflict, both, दोनों से suffer करता है. Only shift reduce conflict no, as I told you दोनों से suffer करेगा. Reduce reduce conflict no, both shift reduce conflict and reduce reduce conflict yes, दोनों सफ़र करेंगे शिफ्ट रिड्यूस पार्सर को. सो ऑप्शन डी इज करेक्ट हेयर. शिफ्ट हैंडल एंड रिड्यूस हैंडल कंप्लीटली ब्लाइंड ऑप्शन, मतलब बिल्कुल ही अलग ऑप्शन है. सो ऑप्शन डी दैट्स वाई रॉन्ग. सो विच ऑप्शन इज करेक्ट हेयर? ऑप्शन सी इज करेक्ट हेयर. सो अगेन ए गुड क्वेश्चन, दे कैन आस्क यू दैट टाइप्स ऑफ क्वेश्चन. ओके, आप अगर प्रीवियस इसके पेपर भी देखोगे तो सिमिलरली एग्जैक्टली बिल्कुल ऐसे क्वेश्चन हैं उसमें भी. ठीक है, दिस इज द क्वेश्चन नंबर 9. लेट्स सी. Read the question carefully. Grammar of the programming is checked at which phase of the compiler? So as you know that variable syntax analysis phase, at the syntax analysis phase we need to use what? Grammar, CFG grammar, context free grammar, to verify the syntactic structure of any programming language. किसी भी प्रोग्रामिंग लैंग्वेज का सिंटैक्टिक स्ट्रक्चर को वेरीफाई करने के लिए हमें सिंटैक्स एनालिसिस फेज पे एक ग्रामर की ज़रूरत होती है. वो ग्रामर होती है कॉन्टेक्स्ट फ्री ग्रामर. उसके थ्रू हम उसका सिंटैक्टिक स्ट्रक्चर वेरीफाई करते हैं. किसका? प्रोग्रामिंग लैंग्वेज का. अब इसको पढ़ लेते हैं क्वेश्चन, बड़ी जल्दी से आप आंसर दे दोगे. ग्रामर ऑफ द प्रोग्रामिंग इज चेक्ड एट विच फेज ऑफ द कंपाइलर? सिमेंटिक एनालिसिस नो, कोड जनरेशन नो. As I told you, at the syntax analysis phase we need a grammar to verify the syntactic structure of the programming language, of any programming language. So yes, option C is correct here. Option C is correct here. Okay, so option D is again wrong. Code optimization no, it's again wrong. So which option is correct here? Option C is correct here, guys. Okay, so this is again a good question. Let's see the last question of this video. Which of the following expression is represented by the past tree? Various times they ask that types of questions. Easy question, but they asked that types of question. So this is a given past tree. They want to ask you the expression which this past tree will generate. Okay, so from here you will get what? A plus B. From here you will get what? A plus B, and from here you have what? A plus B, and here you have what? C at the same level, and they are going to do what? Asterisk. So here this A plus B asterisk C, yes, first we evaluate what? A plus B, then after C. So here option is given A plus asterisk B C, no, completely wrong option. A plus B asterisk C, no, completely wrong option. A asterisk C plus B, no, completely wrong option. A plus B asterisk C, yes, option D is correct here. Okay, so these are the 10 questions, most expected questions they can ask you